All right, guys. Hey, my name's Matt. Just a quick little introduction about me. I was in First LEGO League in 2005 and 2007 in the Peoria area. I was actually on one of the very First LEGO League teams in the area there. During my time, I had the fortune to compete in the Open European Championships, which is kind of like the championship event for Europe, where the team that I was on, we actually got the programming award in 2007. So that was awesome. It was a huge honor. Since then, I did first throughout high school, and then I went to college at University of Illinois. After graduating from there, I started working for Caterpillar in Peoria, and now I have recently moved out to Pittsburgh to start a new job with Google. However, even though I'm no longer living in Illinois, I'm still really happy that I can connect with everyone and still kind of give back to the community that really got me started on that journey through things like these webinars. And then I'm also planning on coming back to volunteer at the championship, the Central Championship tournament. So you might see me around there too. All right, so just a quick note as well, just a reminder, if you're not speaking, please do mute your microphone so that way there's not any background noise. However, if you do have questions in the middle, feel free to speak up. It's okay to keep this kind of open. If there's something that doesn't make sense or you understand what I'm saying, just chime in. All right. So first up, I hope were all able to install the EV3 software. You can download it for free on LEGO's website. They have it for Windows and for Mac. When you first open it, this is kind of what it looks like. It's got pictures of the different robots that you can build with the kit, but you don't really need to worry about that too much. What's important up here is this little plus button. You can click this. It says Add Project. That's basically going to create a new project. Now in EV3, your programs are all stored within a project. So there's this structure, programs inside of projects. And so this is more familiar for what you're going to see, this view, when you're working on your EV3 code. It's got this white window where you actually will insert the commands for your robot. The EV3 software is considered a graphical programming language, and so the way it works is you actually put blocks in a line, and your your robot basically does the instructions indicated by these blocks left to right. You can make this little tab thing go away by just clicking that button up there, and now we have some more space up here. So anyway, this whole programs and projects thing. Now, once you've created a project or you have a project open, you can have more than one program in that project, and you can rename them by just double-clicking them here. So we can have my program 1, my program 2. Those programs are all stored within this project, and when I click this Save button over here, or if I just click File, Save Project, this is my first time with this project, so I'm going to need to name the project. So I call it My Project, but now that I've clicked Save for the project, all of the programs are all saved with it. And now if I actually go into my Windows Explorer and I go Documents, LEGO Creations, Mindstorm's EV3 projects, you'll see that this, my project.ev3 file is here. But even though I've got two programs, just one file is showing up here, and that's because these programs are actually hidden and stored inside of the project file. So they are here, they're just inside of this file. So, okay. You also have this wrench tab here that's for project properties. And in here you can see the different programs that are a part of this project. We'll come back to this a little bit later. There's a few things that you can do with this. But again, we'll worry about that later. So, okay. Now this is the normal programming screen, and when you have a program open, you'll have mostly, you'll have this is the start of the program, and then a bunch of white space for you to use to put your program in. You can actually, and just to illustrate this, I'm going to put some blocks out here. Don't worry about what they do. You can move around the screen by using this pan tool, clicking and dragging around. And so that's one way to move the screen around. Another way is if you don't have any blocks selected, you can use the buttons, the arrow buttons on your keyboard to move the screen around. So that's another way to move around. You can tell which blocks are selected by the light blue outline around them. And you can highlight more than one block by clicking and dragging, and then you'll see I have 2 blocks highlighted. I can drag these together as a unit, and I can delete them by hitting the delete key on my keyboard. Down here at the bottom, you saw me earlier, I was dragging some blocks out into the program area. These tabs, these are called palettes, and these contain all of the different blocks that you might use to program your robot. We're going to just stick with the basic ones today, so we're not going to cover all of them. But if you're interested in learning more, I'm going to be hosting an advanced programming webinar in a few weeks. So be sure to look for that if you're interested in getting into more advanced topics and using all of the different blocks in some of these palettes. If you're not sure the name of a palette, just hover your mouse over it. This first one's called Action. Next is the orange is Flow Control, yellow for Sensor, red for Data Operations, blue for Advanced, and turquoise for My Blocks. We will be sticking to the Action, Flow Control, and My Blocks palettes. Oh, one more thing that's worth noting for controls. There's this zoom out and zoom in. You can click the zoom out button. You can click zoom in. And if you want to reset back the default zoom level, click this 1-to-1 button. Also, if you hold down the control key on your keyboard and use the scroll wheel on a mouse, you can also zoom in and out of a program, which is also very nice. One last important note up here, I don't want to skip over this, is the comment button. If you click this comment button, it generates a comment block that shows up here in your program, and you can drag it around, and you can type in it. This is useful for a few reasons. Number one, if you have a student who's working on a program, and for some reason, that student was sick and is not able to come to practice one day, if there were comments like these written throughout the program, then the other students are going to be able to understand what the student who's not present was thinking. And you're going to be able to work better even if that student is not there to answer questions. Another important use of comments is for the judges. When you go to the competition, you're going to need to print out your software and give that to the design judges. And they're not really going to be able to tell very easily what's going on by just looking at the blocks, by looking at the pictures. But if you have some comments, it helps explain what's going on. And now, you don't want to just say the robot is driving. That's not a useful comment because you can see that the robot's driving usually just by looking at the block. A useful comment would be drive towards, X mission, and have some kind of information about what the robot is doing with respect to its surroundings. Right, so that's the comment block. Again, you can click it, and you can have more than one of these. You can drag them around and resize them as you need. Okay, so now earlier I talked about how there's projects and there's programs within projects. Now, if you're going to use more than one computer to work on software with your team, odds are you're going to have you're going to have a one computer with a project on it, and then you're going to have another computer with another project on it. So I'm going to go ahead and simulate that. I'm going to make this project. So let's say you had those two computers, and each one of them has to each one of your computers has a project. Now, in the end, you're going to want to put all of your code together in one project for the competition. You can do that. You have to actually use the tools in this project properties window to combine them. So if we wanted to bring program 3 into this first project, I'm going to have to first export it by going into project properties, clicking program 3, and then clicking export. And now I can export program 3. And if I go back to the first project and now click import, I can see that the program 3, the separate program 3 file has now been created, and I can import that program 3. So now I have access to it in this project. So if you're going to be using multiple computers, be aware that you need to export and import and shuffle your files around. If you're a new team, I do recommend trying to keep it simple and using one computer. That way you don't have to worry about copying files over like this. It can get a little tricky sometimes. One other tip with the whole projects thing is I do recommend taking after each competition and after each scrimmage, saving a copy of your project and naming it, scrimmage 1 code or regional code or state code. That way you have versions of your code, maybe even every week or every 2 weeks you decide that you're going to save the project just to back it up. I do recommend doing that because who knows what could go wrong. Oh, yeah, so I see there's a comment here. A team recommended using Google Drive. I have not actually done that before, but I think that's a great idea. So if you're looking to have more than one team or more than one computer on one team, you could have Google Drive or Dropbox or something similar installed on both computers and have your code in the shared folder. All right, any questions so far? Okay, so next, I hope you guys have your robot with you, because there are some exercises. We'll have a break here in a little bit just for you guys to work on some lab exercises. But I want to go over the brick a little bit just so you guys are familiar with the buttons and the menus on the brick itself. Feel free to turn on your brick and follow along with this. So to turn on the brick, you hit the dark gray button in the middle. That's the enter button. The EV3 brick does take some time to turn on. So I recommend that when you go to the competition that you have your robot turned on before you actually step onto the field. When you're waiting in line getting ready to go on, make sure that it's powered up so that way, because if the timer starts and your robot isn't turned on, you're going to have to wait for the robot to turn on and you're going to miss out on time to actually run your robot. So make sure it's turned on beforehand. Then you have some up, down, left, right buttons, and this button up here is the back button. In order to run a program, you need to find it in these menus and then hit the enter button to start it. And if you want to stop it for some reason, if it's running into a wall or something like that, you hit this back button. The back button will stop it in the middle, even if it hasn't finished the end of the program yet. Okay, so these different, if you hit the left and right buttons, you're going to go through these different tabs, these different menus in the brick. This first one is Run Recent. It shows a list of the most recently executed programs. The next one is File Navigation. It shows the programs that are on the EV3, and it organizes them in folders for each project. So when you download code to the EV3, you download it by an entire project. You send an entire project to the EV3, and so those programs show up in here in that project folder. And you can run them by selecting them in this tab, in this File Navigation tab. The next tab is Brick Apps, and here there's two useful tools. One of them is the Port View tool, which you can use if you have sensors plugged into your EV3. You can view those sensors using that Brick app. And it's fairly straightforward. If you go into that and you hit enter, you can see you have to select the different type of sensor that you want to read, and then it will display the sensor's value on the screen. The other useful brick app is the motor control brick app. The nice thing about that is if you're trying to design a new arm attachment and you want to quickly run tests just to make sure that the arm has enough, or that the motor has enough power to raise that arm, you can use this motor control app to quickly just drive the motor manually using the buttons on the EV3 brick rather than having to write a whole program and download it and run the program. So it's good for quick testing and quick prototyping. The last tab on the EV3 menu is the settings tab. The important part here is to use this if you want to set up a Bluetooth connection or if you want to set up a Wi-Fi connection with your laptop. I definitely recommend looking into that because it's pretty helpful to be able to just download code to your robot wirelessly. And there are also some debugging functions that you get to take advantage of if you are connected wirelessly. All right, any questions on...
Hello?
Hey, yep. Do you have a question?
We're having problems. Yeah, we're having problems with our Bluetooth. So what do we do?
So I cannot exactly help you with that here. I would suggest looking. So there are other teams who've used the Bluetooth before. I actually don't have my own EV3. I've only ever borrowed other people's. And I would suggest looking online. If you need further help, I can help you guys. But my first suggestion is to maybe post on the FLL Yahoo group and see if anyone else has used the Bluetooth and can help you out with that.
Okay. Okay.
Okay.
Thank you.
Yep, you're welcome. So, moving forward now, in order to write programs for your EV3, you basically will find the blocks that you want in the bottom here, and you will click once to select that block, and then you will drag and place the block in the line. You can insert the blocks in between. If you do have a really large program, you might see it lag a little bit. You'll drag and hover this over, and for some reason they're not moving very quickly. Be patient, because with the really large programs, it can get pretty laggy, and if you don't wait for it, it can corrupt the program. So I know it can get frustrating, but if you're using an older computer and it's going slow, just be patient with it. So these are what the blocks generally look like. They have a little, this says B plus C here. They have a little letters or numbers up here in the top right. And then in the bottom left, there is a button that you can click. This is the primary setting. And you can change what the block is doing from a top level perspective. And then these regular settings are used to actually configure the details and the specifics of what the block is going to do. And if you're not sure what something is, you can hover over and you'll see this says steering, power, rotations. And so you can kind of hover over and see what that setting is for. You can click on them and type or drag these sliders and click on buttons in order to configure this block. All right. So once you have your programs written, you can actually download them to the EV3 by clicking this button in the bottom right here. Well, I can't click it because I don't actually have an EV3 plugged in, but if you have an EV3 brick plugged into your computer, you can download them that way. This button just below it is the download and run button. So be careful with that, because if your EV3 is sitting on the table and you click the download and run button, it's going to download and then immediately start driving. So it could, be careful. Don't let your robot drive off the table. Another important note is when you click this download button, it downloads the entire project, not just, just this program. So you'll notice that when you click that button, the whole project showed up. Well, that's just how the EV3 works. downloads the entire project. All right. And then again, to run your programs, once you've downloaded them, you just go either into the Run Recents tab or into the File Navigation tab and use the Enter button and the up and down arrows to select the program that you want to run and hit that Enter button to run it. And again, if it's doing something bad and you need to stop it, hit the back button. That's this button in the top left. That will stop the program. Okay. Do we have any questions so far? All good? Okay. So now let's start talking about some of the blocks and what they actually do. Oh, yep. Do you have a question?
Hello?
Hey there.
Are you Builder Dude on YouTube?
No, I am not.
Oh.
Yeah. Okay, so actually, actually getting a robot to move. First step. We'll go through some of these blocks. There are 4 blocks to cover that are pretty similar to each other. So bear with me, but fortunately once we get through the first one, the rest of them are basically all the same. So I'm going to start off here with this block. It's called the Move Steering block. If you hover your mouse over it, you can see it says Move Steering. It has a symbol here with 2 motors, and that's intentional because this block can only drive 2 motors at a time. It cannot be used to drive just one motor. So you can select which motors. I guess I skipped over this. I'll take a step back. Your EV3 has plugs on the top and the bottom. There's 4 plugs on each side, and they're labeled A, B, C, D, and 1, 2, 3, 4. The A, B, C, D ports are for motors, and the 1, 2, 3, 4 ports are for sensors. So when you're in the programming software, you just need to tell it which ports the motors are plugged into that you want to turn on. So we do ports B and C. That is different than C plus B. This is designed so that whichever, when your robot's pointing straight, in this case, I've configured it such that C is on the left and B is on the right. If it's the other way, if B is the left motor and C is the right motor, then you should do it like this, B plus C. Next, you select the primary setting. These motors actually have sensors in them that can detect the number of rotations that the motor has performed. And so that's what this is for. You're saying, I want to turn on the motor for a specific number of rotations or a specific number of degrees. You could also choose for just a number of seconds, and then we'll get back to these on and off settings later. But let's just say you wanted to turn on for, a number of degrees. So you'd select that there, turn it on for degrees. Then we'll go across these settings here. The next one you see here, it's steering. And if I drag this, you can see how that arrow kind of bends to the right more and more the further that I drag this slider. And also to the left if I drag the slider to the left. This is indicating that the robot's actually going to arc to the right as it drives forward. And now the best way to do this is to test with it. So, try one of these settings and see if it's arcing or if it's turning right for you. If it's, it needs to turn more, or if it needs to turn less, then come back and change this value and try it again. You'll notice that if you drag the slider all the way to the right, you see this circular arrow symbol. What that's indicating is that the robot is actually performing a counter-rotate turn. Counter-rotate turns is different than just a regular turn. What it means is the wheels are turning in opposite directions. So in this case, the left wheel is turning forwards and the right wheel is turning backwards. And this causes the robot to spin about its center. Be careful if you do this, the robot will turn very fast. So it might be uncontrollable sometimes. So just be careful. But sometimes it's necessary if you're in a tight space and you need to make a turn. Otherwise, you can make a turn by putting this value pretty far over And usually, you'll see that the right motor is stopped. It's not driving at all, it's just stopped, and the left motor is driving forwards. And so then you're swinging around your right wheel. So that's what this setting is, this steering setting. The next setting is power, and that's 100 for full forwards for full power, and negative 100s for full reverse power. Be careful too, because usually if you're trying to go fast and drive across the field, it might make sense to use 100 power. But sometimes, your robot will skid or slip if you use too much power. So make sure you use the right amount of power so that you're going fast, but you're still under control. Rotations. Here I specify how long I want the motors to turn on for before stopping. And I can put, a decimal here. I can do 1.5, and it'll let you go pretty far. Here, I can go, see, you can't even see it anymore, but I did 1.555. So it actually, it's pretty precise. It lets you set values for this that are
program the Lego.
Hey guys, just a reminder, if you're not talking please, or to the conference call, please mute your microphone. The last setting on the move steering block is brake at end. If I click this, I can choose brake or coast. Those are, so essentially they do what they sound like. If you choose brake, then the motor will lock itself, will stop at the end. If you choose coast, it will just kind of freely just coast at the end. Generally, you want to use braking if you want to stop at a certain location. With First Lego League, you generally need to do that. You need to stop at a specific spot and then lower your arm or pick something up. However, if you're trying to transition smoothly into another action immediately after this, it might make sense to use coast. So I just encourage you to experiment with it a little bit to see what the difference is like, and then choose the one that works better for the situation that you're in. So that's the move steering block. Next up, we have the move tank block. This block is very similar to the move steering block. You'll see that it also has two motors on the icon, just like this one, and it's also only able to turn on two motors at a time, just like the move steering block. The only difference here, so you'll see these options are the same in the primary setting. The only difference here is you'll see we have a power left and a power right, whereas before we had a steering and a power. And so this just lets you set the specific power values of each motor, the left motor and the right motor, separately. And I can do, an arc turn like this. So this is going to do an arc turn to the left. I can also do a counter rotate turn. So I can still do all of the same things that I could do with the move steering block. It just kind of depends on what works, what makes more sense to you and what do you think is going to be easier. Whatever your team does choose, I encourage you to use the same one across all of your programs. And then the other settings are the same. Turn it on for a number of rotations, and brake or coast at the end. All right, so those are the move blocks. There are two more blocks that you can use to turn on your motors. You might have been wondering at this point, well, what if I want to turn on just one motor? What if I only want to drive my arm and I don't want to drive two motors? In order to do that, you would use one of these blocks, the large motor block. This symbol here only has one motor, and that's good. That's because it's for controlling just one motor. You can only select one motor here in the port. Other than that, it's basically the exact same as the move blocks. You can turn it on for seconds, degrees, rotations. You specify a power. Positive is forwards, negative is reverse, and you can give it, a number of rotations and brake or coast. I guess one quick note here about this positive or negative. Depending on the orientation of your motor, positive might actually be backwards. So don't necessarily assume that 100 is always forwards and negative 100 is always backwards. The motor doesn't know which way your robot is built. It just knows which way it needs to turn. So sometimes teams have to worry, they have to deal with positive being backwards. It just kind of depends. So you'll have to test with your robot to see. The last block that you could use to control your motors is this medium motor block. And it's the exact same as the large motor block, but it has to be used if you're using a medium motor, which is, it looks like this, this symbol here. If you are going to use a medium motor, I encourage you to test your attachment and your arm first before you build too much, because the medium motors are definitely a lot weaker than the large motors, and you might find that it's not strong enough for your arm. So just be careful with it. It is lighter and it's smaller and more compact, but it is weaker. So. Okay. Any questions so far on these? So we had some motor blocks and we had the move blocks.
I posted a question.
What do you mean WRO?
World
World Robot Olympiad. Yeah.
I'm sorry, I couldn't hear you. World Robot what?
Olympiad.
Okay. So you're saying your robot kept bouncing. There's a number of reasons why your robot could have been bouncing. It could have just been mechanical design. Is there some specific thing that you wanted to ask about?
No.
Okay. Well, I mean, generally, if the robot's bouncing, one thing to check is that when it's turning, that it doesn't have resistance. So if there's resistance by some other wheels or something else is rubbing on the ground, sometimes the robot will appear like it's bouncing while it's trying to turn because of those other things that are rubbing on the ground. So that would be I would encourage you to first check that, try spinning it with your bare hands without driving it with the motors. Just spin it yourself and see if it feels smooth. If it feels smooth, then maybe just double check things like re-download your program, reset your robot, do all of those quick little things because it shouldn't be just bouncing around on the field.
Okay, thank you.
Yep. Okay, so moving on now to the next palette. We're going to look at one more block before we move to the first set of labs. The one block we're going to look at in here is called the weight block. It's this hourglass one. The way this block works is when your program gets to this block, it will sit here and it will wait until some condition is met, until something happens. And you tell it what to look for in the block settings. And so you could say wait until a touch sensor is pressed. So now touch sensor port 1, don't forget to select the port, is pressed. So it's going to wait here until that happens. Now let's say you wanted to turn on your wheels until, drive forward until the touch sensor hits the wall. So you might think, okay, we'll bring out one of these move blocks. We'll say B and C, we're turning it on forwards. Then, after we've turned it on, we're going to wait until the touch sensor is pressed. Looks good, right? Well, actually, this is incorrect. What will happen is this block will turn on, and then it will wait here, this block. It won't move on. It's going to stay here on this block until this block has completed the rotations. And then once those rotations are complete, it's going to brake the motors and then move on to the next block. So really, this won't do much. It will just drive the one rotation, stop, and then just sit there forever until some human comes by and hits that touch sensor. If you want to drive until the touch sensor is pressed, that's what these other two settings are for that I skimmed over earlier. Just turn on the motors, but don't say on for something. Just say on. And in this program, it turns on the motors, steering is 0, power is 75, and it moves on immediately because that doesn't take very long. It's like flipping on the light switch. It just flips on the motors. And then it moves on to the next block, which is the wait for sensor block. The last step is we need to tell the motors to turn off when we're done. And so this set of 3 blocks allows us to drive our wheels until a specific sensor is pressed or something like that happens. Okay. Any questions on the wait block? All right, so just a couple more notes here for debugging. When you have, so this is the biggest reason why I suggest trying to connect your EV3 via Bluetooth or Wi-Fi to your laptop, is that when you're connected to your EV3 brick, you'll see all of the motors and their rotation sensor values, and you'll see all of the sensors with their values in this port view window in the bottom right here, even while your robot is running a program. So that's a really useful live debugging tool. The other interesting thing is, if you have some blocks out here and you hit this download and run button in the bottom right, then as your robot does this program, you'll notice that this bar, it's this green bar, it kind of sparkles and glistens when the robot is working on this particular block. And then the next one will sparkle, and then the next one will sparkle. And so if your robot's getting stuck, you can look at which blocks are sparkling in order to kind of figure out, debug what's going on. So that's another really nice live debugging feature. Okay, so does anyone have any questions on that? Anything that we've covered so far? Okay, so then let's go ahead and let's take a 20-minute break for you guys to work on completing labs 1 and 2. I'm going to keep this line open. Feel free to come and talk or type a comment if you have a question. And while you guys are working on the labs, and I can answer those. So we will resume the session, the next lesson, at 2:05. And then after that, we will also have another set of time to do some more labs 3 and 4. I'm going to send out via email a little link that you can, with a form where you can click to submit if you've finished labs 1 and 2 already. That way, if everyone gets done early and we want to go ahead and start, I meant at 4:05. At 4:05, we will resume. So if you finish early, just fill out that form so that way I've got an idea. If everyone's finished, we'll just move on and we'll start the next lesson early. So, all right, feel free to start on the labs, and if you have questions, just contact me here. Okay, guys, we're going to go ahead and resume with the next part of the lesson. If you haven't had time to finish the labs, that's okay. There will be more time after this, and then you can always work on them later at home. And you're always free to email me with questions if you're not able to get through it all today. If you have questions tomorrow or some other time, you can always just email me with questions. Okay, so we will go ahead and continue. So now we're going to get into a few little tricks here. So you might have wondered if it's possible to turn on your arm motor while simultaneously driving the robot down the field. With the previous controls that we had, you would have to do the motor, tell it to turn on for some rotations, and then turn on the wheels, or do it the other way around. But how would we do both? The way to do that is to take the block and kind of just drag it into open space here. So let's say we have our motors B and C and our arm in D. If you hover your mouse over the start block here, you'll see it shows this little spool icon. and you can actually click and drag that over to a block, and that attaches it. If I drag this down to the bottom one, now I have split the channel. So now I have two channels. Two things are going to happen simultaneously. It's going to drive the motors forwards while also driving the arm up. Let's say immediately after that, I wanted to reverse and put the arm down, so do the exact opposite action. The obvious way to do it would be to just add this block here to drive backwards after driving forwards. And so you would change that to be negative 75. And then we want to lower the arm after having raised it. So we'll put that at negative 75-ish. This program is technically, it probably will not behave the way you expect. These two channels, once they've separated, they act on their own. So this block will go and it will drive, let's say that this was a 5 and this was a 5, but this was only a 0.5 and this one was a 0.5. So the time it takes for these B and C motors to drive 5 rotations is going to take much longer than the amount of time it takes for D to go only 0.5. And so D down here will be done first before B and C are done. The thing is, as soon as this block here, D, gets done, it immediately moves on to the next one because they're directly connected. And so these two blocks will probably both be finished before this first one has even finished at all. That wasn't what we wanted, though. We wanted it to drive forward and move the arm, and then after both of those are done, we wanted it to reverse and lower the arm. In this case, the way to do that would be to spread these out over here. And we know that this one is the slow one. The B and C are the slow ones. And so we use those as the splitting point for our next set of actions because we know that they're going to be done last. And now this will get the job done. And you can also, if you highlight and click and drag these, they still kind of stay attached, which is nice. So that is splitting the channel. There are ways now, let's say you had two blocks that are both very close to each other in length, as in there's no obvious, in this case it was obvious that the B plus C move block was going to be done after this one. This was the slow one, and we knew that. If there isn't an obvious slow one, there are ways to synchronize your channels. That gets into a little bit more advanced topics, and if you're interested to learn about that, I would suggest signing up for the advanced programming webinar, which is going to be in another few weeks. All right. Moving on. We have a few more blocks to look at. Down here in the flow control palette, we have this big block here. It's called the loop block. This block allows you to repeat certain actions over and over again in your code, and that's what this kind of circular arrow symbol is trying to convey. So you can put blocks in between the ends of the loop, and it will repeat those actions over and over again, and you can configure how many times to keep doing them. So right now it's configured to unlimited. Well, unlimited doesn't really mean unlimited. It means until you hit the stop button on the program, on the EV3. That's the back button. The back button stops the program. You can also tell it to go just for a number of times. You could tell it to go 5 times. You could tell it to go until a touch sensor is pressed. So you can tell it to loop until some condition is met, and then it will stop and move on. If you need to split the channel in these loops, you can do it. You just have to stretch them out using these handles, and then, split the channel here like this. So now I've split it, and I can have another. I could raise my arm or something inside here. There we go. So, I mean, again, you got to be careful when you split the channel because this loop will repeat itself once this top B plus C block, this move block, is done. It won't wait for this one. So if this one's not done yet, too bad, so sad. It's going to start back over and repeat. That's the loop block. Next up, we have this block here. It's the switch block. Now this block asks a question, and it asks that question once right at the beginning. It says, hey, is the touch sensor in port 1 pressed? If the answer to that question is true, yes it is pressed, then it does the code up in the top section. But if the answer was no, then it does the code down here in the bottom section. And it's important to note that this block only asks the question once right at the beginning. So if the touch sensor is pressed and it comes to the top here and it starts doing this action, and while it's doing this action, the touch sensor becomes unpressed, it still stays here. Once it's gone up here, it's already gone. It's gone up here. It can't just suddenly switch back to the bottom just because the touch sensor was suddenly unpressed. So that's how this block works. It asks the question once, right at the beginning. If you needed it to continually ask that question and change its behavior, then that's what the loop was for. So you could use a loop with a switch to continuously check. Hey guys, just a quick reminder, if you're not talking, please mute your microphone. So you could use the loop with the switch to continually check the state of a sensor and do something different based on what that sensor sees. Last here in the flow control is this loop interrupt block. You can place this block anywhere inside of a loop and it will cause it to stop right there wherever that happens to be. So I could put one of these inside here, and let's say, you know, it went down here in the bottom at first, but then suddenly it came up to the top. Now it hit that loop interrupt block, and it's going to skip out of this loop and resume the program right here. All right, and that is all of the flow control blocks. We have the one more palette that we want to look at here is called the My Blocks palette, and this is for you to be able to create your own custom blocks that you can reuse. So let's say you wanted to have a line follower and you didn't want to have to copy all of the code for the line following program every time you wanted to use it. You can actually put your line follower into your own block, and the way you do that is you put some of your so you have your program here, and you've decided that you want to turn this program into a My block. You have to highlight what you want. So I highlighted these 3 blocks, and you can tell that they're highlighted because they have a light blue outline. You go to Tools, My Block Builder, you give it a name, and you can even change the icon to be something that, you know, helps you remember what that block is doing. And then when you click Finish, you'll see that that block has now been created. It's called Do Something, and it's here in my program 1. If I wanted to see what's inside of it, I can double click it, and now I've opened up the Do Something My block. So there it is, and those are the 3 blocks that I had highlighted before when I went into the My Block Builder. And I can also now click and drag multiple copies of it very easily into my program. So I could put it over here too. If you have multiple projects and you want to use the My blocks across different projects, you have to share them the same way. So you notice in my project 2, that my block's not here. If I want to be able to use that my block in my project 2, I have to import it just like I had to do with the programs. So I go my project, project properties. I see here that the my block is listed in the my blocks tab, and I can click export. I can export that my block, and now in this project I can import that my block, and if I now go here, there it is. Now it's in my project 2. So you can share your my blocks that way with different projects. All right, so then the last couple of things to cover here is back in the action palette, there are a couple more blocks that can be used mostly for debugging. Let's talk about the sound block first. This block you can use to play a certain tone in your program when it's doing something specific. So this is mostly, again, this is mostly a debugging thing. So you can have it maybe start with a low pitch and then move towards a high pitch as it completes a program, and then recognize where it's getting stuck because the tune is no longer changing. So that's one way to use the sound block. And then the display block, you can also, you can display text on your screen. The text that shows up is actually what is in the top right here. So you could say completed part 1. And then after that, it does some more things. And then you want it to display some more text on the screen, completed part 2. So you can have this show up on your screen on the EV3, and you can use this information to help you debug. One important note here is this clear screen flag. If you make it true, then it will clear the entire screen and make it blank before it writes completed part 1 on the screen. In some cases, you don't always want that to be true. For example, we might want to show completed part 1 on the screen with completed part 2, so that way we can see the progression. And so here I just changed the row. I changed it to a different row so it would print completed part 2 below. So in the end, what it's going to look like on the screen of the EV3 brick is it's going to say, it will show this on the brick, just like that. If I had checked this into true, then this completed part 1 would get erased when this block executes. So sometimes you don't want this checked in. It just depends on your situation. So that's what this display block could be used for. You can use it for some more advanced display features, but again, that's for the advanced programming seminar. All right, does anyone have any questions up to this point? Okay, so a couple of other just tips before we move on to the last set of labs. We have so just a heads up. I don't know if anyone's using NXT, but you can actually use the EV3 software to program the NXT. That is possible. There is like a compatibility matrix of sorts. So if you are interested in that, I can send out a link to that. So a couple other tricks. The gyro sensor, if you're using it, be very careful. When you first turn on the robot, the gyro has to boot up, and it needs to be totally stationary for at least 5 seconds. So make sure you set the robot down, turn it on, don't touch it, let it fully boot up if you're using the gyro. Okay. Well, so now we have some time. We have a half hour left for you guys to continue working on the labs. I'm going to stick around for the rest of the half hour. Feel free to chime in via audio or via comment here if you have questions. I hope this was helpful for everyone. And then again, if you have questions, if you're not able to finish the labs today and you're working on them another time and you have questions, feel free to send me, a question via email. It's helpful if you're stuck on a particular part to just reference the lab number, the section number, so that way I know exactly what you're looking at and where you're stuck. So, all right, thanks guys, and go ahead and get started on the labs.